Welcome to today's Energy Central webcast entitled How Analytics Can Drive Superior Customer Engagement and Improve Performance for Integrated Demand Response and Energy Efficiency Program. A few housekeeping notes we'd like to mention. For best results in viewing this presentation, we recommend using a wired high-speed internet connection. So wireless connections can be unpredictable. If you cannot get adequate sound from your computer speakers, you may dial it in at any time using the audio portion, using the telephone number in the audio section of the interface in the right-hand panel. Following the presentation, we'll have a brief question and answer period. You may submit your questions at any time using the interface on your screen. I'm now happy to turn the floor over to our first speaker, Evan Pittman. Evan, welcome to the event. You have the floor.
Thanks, PJ, and welcome everyone, and thanks for joining us today. Let me apologize up front for some of the time confusion around the webinar. I think we had a 1 p.m. Eastern start posted at one point, and you guys might have gotten a lot of emails this morning correcting that, so apologies to those of you who are on, and apologies to anyone who missed it and is listening to this on a recording. My name is Evan Pittman. I'm part of our corporate strategy team here at Converge. Joined Converge about 1.5 years ago after attending business school at University of Chicago, and before that working in the Brattle Group's electricity consulting practice. I'm happy to be joined today by Joel Gilbert, who's the co-founder and chief software architect of Apogee Interactive. I think he needs little introduction in this industry, having worked with over 200 utilities over his career. Converge and Apogee announced a partnership last year that's going to enable us to bring Apogee's powerful analytics and engagement tools into the homes of the 2 million residential customers that we've recruited into demand response programs. So we're very excited about that partnership and excited to be together on this webinar today. This is the third webinar that we've had in the past year on this topic of integrated DR and EE, so obviously it's a very important topic to us. In the past, we focused a lot on best practices around program design, how to make a smooth experience for your customers, and how to yield maximum operational benefit out of these programs. So if you're interested in those topics, I encourage you to go check out our archived webinars on our website. Today, instead, we're going to focus on how analytics can drive improved performance in these programs. So I'm going to kick us off by providing a little bit of context around the general approach that we take to integrated EE and DR. Talk a little bit about why thermostat programs in particular are a great integrated EE and DR solution, and then talk about a couple of barriers that we see in the market to these types of programs today. After that, I'll kick it to Joel, who's going to dive into the meat of how Apogee's analytics engage customers and help drive them towards more energy efficient behaviors. So let's start today by looking at a residential load profile. We've got hours of the day here on the horizontal axis, kilowatts of demand on the vertical axis. Converge, we spend a lot of time thinking about these things. Every customer's demand curve is a little bit different, but this is a pretty typical one for a summer day. So what's the problem here? Well, for one, customers' demand tends to be highly correlated with the marginal cost of purchasing or producing energy. So in this second graph, we have some actual prices from a hot summer day in the PJM market that runs the mid-Atlantic electricity grid. And what you can notice here is that just exactly as prices are high, as exactly when it's expensive to purchase energy, is exactly when customers tend to be consuming the most energy. So how does that translate into cost to serve? Well, cost to serve is the product of energy consumed times the cost of that energy. So if we multiply the first curve, the rate at which energy is being consumed, times the second curve, the price of that energy, you get the rate at which the utility is spending to serve that customer in cents or dollars per hour. You take the area under that curve, i.e. the cents per hour times the number of hours, and you get the total cost to serve that customer over time. So I'm going to reference this framework a few times in my comments just to show how different load impact modifications can trickle down into cost to serve for the utility. Now that explanation only considers energy costs. Of course, every utility faces some kind of capacity cost as well, whether it's through an organized ISO that allocates capacity costs or whether it's through the utility building their own peaking generation to meet their peak demand. And as many of you know, in a lot of ISO markets, capacity costs are allocated based on the top 5 or fewer hours of the year in terms of demand. And those capacity costs often are in excess of $50 per kilowatt year. So $50 per kilowatt year allocated over 5 hours can yield a marginal cost of $10 per kilowatt hour during those critical peak periods, and in many cases more, where the capacity price is higher or the allocation occurs over fewer hours. So I tried to show it graphically here, and it didn't even work, because this marginal cost during these critical peak periods is so out of line with the cost of, even a high energy cost of 16 cents that you can't even display it graphically. But worse, of course, is that the customers tend to be consuming the most energy during these critical peak events. So your cost to serve, which is normally a few cents an hour, can spike up to $30 an hour for these customers. So a guiding question for us at Converge is, how do we reduce the area under this cost to serve curve here? In other words, what are all of the cost-effective measures that we can take to modify a customer's load curve to help utilities and their customers save money? To answer that question, we think of the Demand Side Management, or DSM Toolbox. So we're not going to focus a lot on pricing today. If you guys are interested in that topic, I highly encourage you to check out a webinar we did last September on how to enable a successful price-based demand response program. But instead, today we're going to focus primarily on DR and EE. So most of us are familiar with the impact of DR on a load curve. It's all about taking aggressive action to conserve energy during during those times of absolute highest cost on the grid, like the critical peak hours that I was describing a minute ago. And that alone can result in huge cost savings. You see here how that trickles down to cost to serve and cuts off a big chunk of that cost to serve for the utility. But over the years, as we've deployed hundreds of DR programs around the world, we started to ask ourselves, what else can we do other than this critical peak type demand response? So of course, one answer to that is to build a more robust DR resource that can be dispatched more frequently and can respond to issues on the distribution grid, or can respond to milder energy price spikes day in and day out, rather than critical peak capacity events a few times a year. Our other answer is to integrate EE solutions into our programs to drive those day in and day out savings. So when most folks think of EE, they typically think of it as a more uniform reduction across the load curve. But coming from a DR background, we tend to think of EE a little bit more granularly. Not all EE kilowatt hours are created equal. So here, take these two different examples of EE measures, both of them yielding 10% energy savings over the course of this day. The one on the left, let's call it a lighting measure, something that addresses loads in the evenings and maybe a little bit in the morning. Let's call the measure on the right HVAC-focused measure that tends to address loads in the middle of the afternoon when prices are steeper and capacity events are more likely to occur. So how does that translate down into cost to serve? Well, if you do the math, the energy efficiency that tends to address nighttime loads yields maybe 7% cost savings in this example, whereas the measure that addresses afternoon and more peak period loads will yield almost twice as much cost savings at 13%. So it's interesting to note here as well that there's I haven't graphed the effect on revenue, but if you think about the effect on revenue of a utility that is not decoupled, they're losing 10% of their revenue from both of these customers. Now, that might be a worthwhile proposition if you're going to reduce your cost to serve by more than that revenue loss, but that's much more likely to happen when you're taking a measure that's addressed towards peak period load reduction that yields greater cost savings than it is when you take a measure that's addressed to non-peak period measures. So of course, for decoupled utilities, it becomes not so much a revenue issue, but more of a cost allocation issue. And to the extent that you reduce revenue from one customer and don't reduce cost to serve commensurately, you're shifting cost onto other customers. So I don't mean to disparage any particular EE measure here. All EE measures do reduce cost to serve. We just try to think carefully and pick the most cost-effective measures and the most beneficial measures first. And that's exactly why we and the market are excited about thermostat-enabled DSM programs. So these really let us hit almost all of the tools in the DSM toolbox that I showed earlier. Obviously, having direct control over the HVAC system and the compressor, we can do direct load control events that cycle during those critical peaks or more frequently in response to price spikes. For the same reason, it enables software-enabled EE, where day in and day out, we can customize the way the thermostat is running to better suit that premise and to better acknowledge current weather conditions to save energy. In the case of utility or contractor direct installed thermostat programs, it even opens the door for physical EE measures. So while the technician is in the home installing the thermostat, he can do an audit of the house, he can wrap the water heater, he can replace some light bulbs with LEDs, etc. And those measures can be really helpful for those utilities who face aggressive kilowatt-hour reduction goals. But what we're really here to talk about today is the incredible opportunity that these thermostat programs open up for behavioral EE and customer influence. So Wi-Fi thermostats provide two key features in that vein. First, they give us a channel of communication with the customer. Anytime a customer opens up their thermostat app on their smartphone, we have an opportunity to message that customer or to give them graphical feedback on their energy use. And when it's a utility-provided portal, all that can be done under the utility brand, building more trust and a better relationship with that customer. Second, the thermostat, in combination with the meter, provides us with the data that we need to truly engage that customer in a personal and relevant way. So Joel's going to talk in a lot more detail about how we can use that data to present outbound, proactive, and personal insights to the customer that drive satisfaction and keep them coming back. But before I do pass it to Joel, let me just highlight a few of the barriers that we see in the market today to implementing these kinds of successful integrated DSM programs. The first is a rather obvious one. Everyone hears about this barrier, and that's the silos that exist between DR groups and utilities and EE groups and utilities, or separate budgets for DR and EE within these utilities. And so, of course, when these groups are planning separately, the EE group maybe doesn't see enough kilowatt-hour savings coming out of a thermostat program to justify the direct install cost. But if you added in the DR benefit, perhaps that would become a clear win for ratepayers and for the utility. This problem is exacerbated when the customer experience group is separated from DR and EE, and in that case, the engagement benefit and the customer satisfaction value often goes unnoticed. So we encourage utilities to find ways to bridge the gap between these groups and to work on an integrated strategy around their customer journey as it relates to DSM. On the regulatory side, we encourage the initiation of integrated DSM proceedings, like are ongoing in California and other states right now, to make sure that EE and DR goals are complementary, and to make sure that budgets aren't unnecessarily separated, and thus, can't be merged, and both budgets can't contribute to a thermostat program. The second barrier is what I referenced earlier around not recognizing the difference in value between different EE measures. So most regulatory constructs that encourage EE tend to be focused on kilowatt-hour goals rather than cost-saving goals. And even cost-effectiveness tests typically, or in many cases, assign a flat value for every kilowatt-hour saved rather than modeling real impact on the load curve. And of course, that can disadvantage thermostat-based EE and DR programs that tend to produce more valuable kilowatt-hours against other kinds of EE measures. Finally, there's some M&V practices out there that discourage this particular flavor of integrated DSM. You hear people say things a lot like, EE is cannibalizing my DR. And in fact, I'd argue quite the contrary. EE isn't cannibalizing DR, it's really just making it permanent. So, this challenge really grows out of this technical concept of a baseline that we use to measure DR reduction. So often when we're calculating what capacity reduction we've gotten from a customer, we look at, say, the past 10 similar days and what their demand was on those days, and then we measure that against their demand during the DR event. The problem is, if you've introduced a thermostat that creates day in and day out demand reductions, then is that really an appropriate comparison? And I would argue that really instead of comparing the customer's demand during a peak event to their last 10 days, you should think about how to compare it to what their demand would have been absent any intervention whatsoever. If we'd never put a thermostat in the home, never engaged the customer, never taken EE measures or behavioral DR measures. And so to do that, I think we should really think about shifting more to a paradigm of looking at an appropriately selected control group rather than baselining at the individual premise. So with that, I'm going to hand it over to Joel to dive in a little bit more to analytics and engagement.
Thank you, Evan. And as I'm listening to Evan eloquently describe some of the barriers here, it reminds me of just how challenging our total environment is today with, if you will, regulatory rules that have a history of logic, and possibly going forward that history is irrelevant. Because many of those rules were based upon avoiding load growth, and now we have potentially no load growth or may even have load decline. I'm going to focus specifically on the analysis methods that help support the engagement process. While I'll be talking about Apogee's approach to it, anybody out there who's in the analysis business has a similar story that they'll present. What I'm going to, just by way of explanation though, tell you a little bit about how we've approached it for the 22 years we've been doing this. Basically, we use bills where we can get bills, whether under any condition, and meter data, or let's call it smart grid data, where it's available. We don't rely on bills and meter data if they're unavailable. Obviously, we'd fail. So we use estimation methods that I'll describe where bills and meter data are unavailable. But as they say, the truth tends to show up at the meter. And so one of the things that we will talk to you today about is what I call the truth serum that bills and meter data tends to provide in any analytical approach. We are a large player in this space. We serve about 46% of the United States, hit about 56 million residential homes, and we have about 650 utility clients. So we have a good base to talk from, and that will be what I'll share. I'll share kind of the approach ranging from small cooperatives to large investor-owned utilities, and not everybody has the range of tools that we provide to them. But just to let you know how we go to market with these analysis methods, we have a lot of end product areas. Everything from, and historically, one of the earliest client base we had was the energy auditor in the field who was trying to work with the customer. We very quickly, early in the days of processing bills, started to work with CSRs because that was one of the most troubling calls. And one of the things that bothered utilities was the inconsistency that could occur from one call rep to the next. And I'm going to come back to this consistency question over and over again, because in your analysis approach, no matter how you're supporting your energy efficiency and demand response, you really have to worry about not just consistency, but conservative answers to customer questions. Now, historically, we have a deemed savings approach to a lot of ideas in the business. I would suggest you may want to reevaluate that, because deemed savings were fine for the old regulatory model. But when a customer is to be engaged, they probably want to know what's in it for them, and a deemed savings measure may not be appropriate. Over the years, though, with the IVRs that have replaced a lot of the CSR conversations that used to occur with the customer, we built our tools into the IVR. Bill print, which seems to have taken off again to get to the hard-to-reach customers, we've done that. Of course, you'll always have direct mail and email. One of the latest ones that I'll spend quite a bit of time on is video, because today's consumer has moved from a reader to a viewer, and we'll talk a little bit about that difference in how they want to be engaged. I see all too many vestiges in our approach that we're assuming and hoping that people will read, and anytime you do that, I would suggest that if they're going to read, keep the words down and try to be as visual as possible. And of course, historically, we've been an online provider. Now, what's gotten interesting, and there's mixed views around it out there, is the power of social media. I will just tell you, it's either your best friend or your worst enemy. If you get it right, it can be your best friend, and it can be a very good early warning signal where things go wrong. If you let it get ahead of you, it can be your worst enemy. I think there are several of you out there who know all too well about it. For years, though, my wife and I, who built the company, have been really, really focused on the schools. because raising the next generation of energy consumer was something that we just felt was a societal requirement, because the schools don't prepare children for life very well. And this energy awareness and energy sensitivity is a life skill. No matter where you go in the world, energy is going to matter. So I personally wonder why we don't make a big deal over it. So just from a historical perspective, we've had some of these players have gone. Control4 has left the space. So for those of you who are looking to the right and seeing the device called the EC100, that device is no longer supported by Control4. They went into the business. They could have been a thermostat provider. They could have been quite a player in this business. They failed. And the reason they failed was at the engagement level. So one of the reasons why we're so excited about the Converge-Apogee partnership is this question of consumer engagement. And Evan mentioned the words, but I'm going to repeat them because they're the centerpiece of all of this thought. First thing is, it has to be a trustworthy engagement channel. The customer has to feel you're being helpful, you're trying to be, if you will, relevant to them in their own world, and you're not just talking to them over their head or about things that they can't do anyway. And so this relevance question is really important, and especially if you can be proactive and personal. The idea here is, rather than wait for the situation to have occurred, if you can alert them in advance that something's about to happen, customers automatically feel that that's very relevant. They may not do anything about it, but at least they know, oh wow, it was going to get very hot, or it is going to get very cold, and if I don't do anything, I'm going to incur a cost, as Evan so aptly pointed out. Now, over the years, we, as well as everybody else, have relied on the M&V consultants to tell us what were the impacts, because many of you, that's the business case. You know, what is this worth? And one of the things that Evan and we, Converge and Apogee, will prove this summer is, what is the combined impact when you put these tools together? And there'll be several case studies that will go through the M&V process this summer. We're kind of excited about seeing what those are. What I'm sharing with you here is just when you work with customers on bills alone. And when you explain bills to customers in a personal and proactive way, we've proven time and time again you get about a 3.5% savings. This is not normative comparisons. Normative comparisons, just telling somebody they're overweight, is not explaining why they're overweight. And normative comparisons will get you 1.5 to 2. But if you actually go and explain to a customer where their energy is going and what they can realistically do about that in their own home, you'll routinely get 3.5 to 4. And we've obviously, averages are just that. So on the big customers, you might get a larger impact, and on other customers, you might get less. But it does average 3.5 to 4. But one of the things that's has gotten terribly important today, especially in low income, is the issue of customer satisfaction. Many of the utility execs today have a direct salary implication if customer sat falls, and rightfully so. And what's happened, though, is in the low income group, the customer sat has been falling. They feel like they've been victims. And so by helping customers with a proactive personal set of information, you obviously can lift it. Now, there's a little problem in what we're doing with Converge on these demand response programs, in that, in general, the devices that we're talking about don't go into the low-income group, because in many cases they don't have Wi-Fi in their house. But what I would like you to think about, for those of you who are looking at this question more broadly, is if you proactively give this low-income group personal information that will help them manage their energy bills, you will lift customer sat. That has been proven over and over again. Also, when you present programs that you're trying to promote in context with this same information, you get enormously deeper penetration of those programs, because you've frankly made them relevant at the time that they're finally engaging their mind on thinking about that program. So this whole thing is all about personal, proactive, relevant information to help the consumer make a decision. Let's make sure we go here. I may have just... Let me just, let's see here. Lost control of the mouse. Ah, okay. But you know what? Customers can't be relied upon for things that are known about their house. One of the things that is a little alarming to me, and it's alarming to any energy auditor, is you ask a customer what they have in their house, and they may not accurately define or describe it. So one of the things that's kind of exciting about our partnership with Converge is when they put an installer out there, that person is a trained person and can actually independently verify what's in the house. And couple that with bills, and you can really provide energy disaggregation that's probably relevant to most customers. But what happens, unfortunately, when you rely on a customer to fill in the profile, you get some strange things, partly because the average American doesn't really know what they live in. And so it's nice to have a controlled source for information as Converge actually implements their program. Obviously, the more information, the better your disaggregation can occur from bills, or the better your energy bills can be estimated. So many people wonder, how accurate can you be in estimating bills, and do more inputs necessarily give you more accuracy? This is a fascinating question, and there are a lot of industry consultants who spent their decades of time trying to define it. Let me caution you, it's the old story, garbage in, garbage out. If you do know the critical variables, size, age, basic system definitions, and most importantly, thermostat temperatures, you can estimate the bills pretty well. Well, if you think about what I just said, the installer for a Converge system will know pretty much the size of the house, will know pretty much the age of the system because they'll be there at the house, and the Converge system will tell us what the thermostat settings are. And so you can estimate bills pretty accurately where they're not available. And so we're pretty optimistic this is going to work very well. But the beauty of bills, or at least meter data, is the ability to track and feed back to the customer. And that is the single element that I think we together as two companies, we believe is going to be the most transformative. It's not just, if you will, getting them into the program, but it's providing them the feedback, giving them the sense that they are in control, and then as they start to learn the power of setting that thermostat more efficiently, not only just from a, if you will, kilowatt hour perspective, but also from a time perspective, as Evan pointed out, we think there's an interesting possibility here to create a dynamic customer. A customer who is not just set and forget that thermostat like most do, but might have a context around this engagement. And one can imagine in a perfect world that all of the economists wish we lived in. The fact is, as dynamic prices were more common, you can almost imagine the customer who, if you will, puts a algorithm in to reflect the way they would like their home optimized in a dynamic price market. We can all think about that and kind of relish that future thought. Meanwhile, we live in regulated rates and markets that don't probably permit all that. What I'm trying to suggest here, though, is you can, obviously, once the thermostat is being monitored by the Converge system, pick out the biggest energy users in the house, which is typically the heating and the cooling system. But the fact is the rest can be disaggregated. And it's pretty easy to do. Well, if you know what you're doing, it's pretty easy to do. Some of you may question, well, Joel, how accurate are you, and how do you know you're that accurate? Well, there is a little serendipity here I just want to point out that happened when President Obama's first term as president. He actually was about to launch a program called Cash for Clunkers. He had done Cash for Clunkers to take old cars off the road, but he was going to spin up a $6 billion program to retrofit houses. In the process of doing that, one of the questions that people worried about was the software to predict savings accurate? And what happened was the DOE, Department of Energy, EPA, ordered a study to be done. The study was done by NREL and LBL, Lawrence Berkeley Labs and the National Renewable Labs, and it was about almost a 2-year effort to look at all the software providers and how accurate the savings predictions are. Now, before I show you, you see our results here, but before I, just bore you with detail, let me explain why. And this is a bit of embarrassment, and those of you in California are fully aware of this embarrassment because you're in the process of trying to undo it. What had happened was, up to this point, a lot of the software that had estimated savings was exaggerating the savings, And indeed, that might have been beneficial to indicate to a customer that they had a big opportunity to save money if they retrofitted the houses. But it then failed what I call the engagement test. And that is, if you promise something and don't live up to that promise, you disengage with the consumer and you almost never get them back. So the characteristic that I like to remind people when you work with customers, is don't overpromise. If anything, underpromise a little and then overdeliver. We all see this with storm events. When you tell somebody that it's going to take 7 days to restore power and you restore it in 6, you're a hero. If you tell them in that same event that you're going to restore it in 5 and you take 6, you're a villain. So what you want to do is to be always telling the consumer, the customer, what they can realistically save, and it better be realistic. And what had happened, unfortunately, is the tools out there that were being used to estimate savings were wildly exaggerating the amount to be saved. We participated in this, ironically, because we didn't want to be ruled out. A lot of these firms are world-class firms, and when they did this evaluation, which was called Best Test EX, for those of you who are geeky, they had a total of, as you see there, of about 160 quiz questions that had to be answered. So each of these test banks were a series of questions that had to be answered by the software automatically. And the software had to get to the right answer, and the right answer was deemed to be the detailed hourly models that many of you know as DOE2 or Sunrail or one of the other models. And so we scored an average of 90%, or said very simply, we were within 10% of what was deemed the correct answer. We don't know who these others are that are on this chart. We really don't. We know who was there, but we don't know whose numbers were which. You could say, well, what's the difference between these test bank 1, 2, and 3, Joel? Well, as you probably can tell, the questions got harder. And what happened in test bank 1, it was heating only, and it was a relatively clean set of examples. What happened in test bank 2 is they went to cooling. When they went to test bank 3, they started, if you will, lying about the assumptions that were present in the math. In other words, they actually, what was said that was true in the house wasn't true. And they wanted to see how sensitive some of these variables would be to your predictions. Fascinating effort. It was documented in a large study. This was about 2 years of work. Some of the greatest minds in the business did it, including Michael Blasnick and others. And it was fascinating to be part of it. The only reason I'm telling you this is that, you know, it's one thing to disag a bill, but it's another to help a customer know how much they can save. Because in this engagement question with the consumer, you really have to worry about that trust factor. And one of the things that concerns me is a lot of what you see out there about savings predictions of up to X may not be achievable at all. And what you do is you bait the consumer to think they have a big opportunity by doing something, and it is unachievable. And so I really get worried about this process with consumers. Let's see if we can get this next slide here. We're getting close to the end, Evan. Okay. Just so that you can see how we've approached it in the past, I'm just going to give you an illustration of how we approach this from a bill analysis. What we're working with Converge is we're going to be in the background. And if you will, all of these details and math will be used for them to power the tips and the ongoing engagement with the customer. And what we have off to the left on the simple inputs, the kind of a form that their installer will fill out. But what you see to the right are the kinds of opportunities for customers to save. One of the most exciting ones, of course, is the ability to get them to change their thermostat dynamically as they learn about how their house behaves, and to give them a sense, even when smart grid data is not available, of how much money they're going to save by the time they get their bill. One of the other things, of course, customers are always interested in is how am I doing compared to others who have the same house? This is not a normative comparison. This is an actual customers like me comparison. One of the things that I really like about this is that in this case, the customer is actually doing a better job with their air conditioner, but they're, if you will, using more other things in the house. And this can be, of course, a person who's working from home. This can be somebody who has, as my daughter has, 20 big screen TVs in her house because her fiance is a sports nut. there are all kinds of reasons. And so one of the things from a relevance perspective you want in the tips is if the customer is doing a good job on their air conditioner, you should be saying good things about that. And then indeed, if their energy use in aggregate is higher, you want to offer them a tip that might help them understand about the rest of it. Okay, let's see here. Clicked on the wrong spot. What we're going to work together with ConvergeOn, though, is this engagement platform. I'm showing you a mock-up of one of the screens we're considering, and that is to use weather as one of those elements for consumer engagement. This may not be in version 1 for the summer, but this is on the roadmap because we both believe that the average consumer will look at one thing every day, and that is the weather. So if we can together create the weather application to get a consumer to look every day at their system and to see what the upcoming weather is all about, we have the opportunity, of course, to influence not only the thermostat setting during that period and get some of those base savings that Evan was talking about earlier, but then potentially to reach deeper during the event by letting them see just how costly that event will be. In other words, very simply, the market may have a certain value for demand response, but in a sense, the natural nature to that hot day, they might be able to save quite a bit, and they wouldn't ordinarily know that. I'll now turn it back over to Evan.
Thanks, Joel. So let me just add a little more context then around what this joint Converge and Apogee solution would look like. Joel described it well there on that last slide, but just a few examples of the kind of powerful messages that we can get to consumers when we have a device in their home, insight into what's going on there, and a great channel of communication with them, whether that's through the thermostat portal or email or push notifications on their smartphone. So, using Apogee's analytics, we can do things like send extreme weather warnings with estimated bill impacts to our customers, give really targeted behavioral DR messaging with suggested actions based on what we know is in that home, can nudge customers towards more efficient set points on their thermostat with highly accurate savings estimates that don't disappoint them when they don't materialize, automatically adjust their schedule based on what we know about the weather and their household to preserve their comfort but save energy every day. Give customers motivating feedback on their progress periodically, send video messages that are customized to that customer, and finally nudge them into other utility programs that are well suited to them to drive even more efficiency savings. A couple things that came to mind while Joel was speaking, we focused a lot in this discussion around direct install thermostat programs. I mentioned some of the physical measures and information that technicians can gather while they're in the home. And those are great benefits of direct install program, but that doesn't mean that all of these benefits don't apply to a bring your own device thermostat program. We still have visibility into the meter data. We still have visibility into the thermostat data. And we can even wrap a utility engagement portal around that bring your own device and provide these great insights to the customer in that case as well. Also, we didn't talk a lot in this webinar about how analytics can help us target the right customers for programs, but we're happy to have more discussions around that anytime. And then the final thing, I know there's often a concern around thermostat-focused programs that they're not going to reach all of your customers. And of course that's true. Not everyone has central air. You're not going to get a thermostat installed in everyone's house. But I do think you'd be surprised at how high penetration can be achieved with these programs. We've had markets where we've installed thermostats in more than 50% of the eligible households in a market. So a couple of parting thoughts there, and I'm going to look now at the question list that we've gotten in. And if you have any other questions you want to submit, please do so through the chat window. So Joel, let's start with a question for you. I'm sorry, I've lost my question sheet here. So how do you quantify results and savings when you're providing analytics like these to the customer?
Well, most utilities will use an independent consultant to do the measurement and verification of the savings impacts. And most of those consultants will use a control group that's composed, in a sense, after the participant group has been identified. They'll go, if you will, take the customers who have operating demand response systems and then look at their attributes and find a control group of customers who have not, and then just take a look at the energy use characteristics of both of those groups over time. One of the nice things, of course, Evan, about your system is the, if you will, richness of the information that you'll get from a telemetry perspective on what the customer's actually done. So let me put this in perspective, because I don't think the average person out there realizes how powerful control programs like this are. We all hear of the 1.5 or 2%. I'd like you to think about that as 0.2 degrees of an average temperature change for a typical thermostat. 0.2 degrees. It's really nothing. And the opportunity to get numbers in the 6 or 8% range just with a thermostat program shouldn't be that hard to achieve at all if we can engage the consumer, because that's only 1 degree on average. And so if we think about helping customers understand how their home behaves and how they can lower the average temperature of the winter or raise it in the summer, you think about 6 or 8 being not a big number.
And when you say 6 to 8%, Joel, you mean whole home savings?
Yeah, not just the HVAC. You can easily get to 6 to 8% on those peak months.
And are those savings, when you use behavioral science techniques, are they sustainable in the long term?
Yeah, that's a fascinating question, and every utility's results can be a little bit different depending on the education that went into the event in the behavioral program. We had ours tested by Navigant and in a big program in Ohio, and obviously there's an atrophy on year 2 over year 1 if the messaging hasn't persisted. But it's only about 30%. So for the 3.5% you get in year 1, you lose, let's call it 1% to down about 2.5% for year 2. Year 3, it's down to about 1.5 to 2%. So the point is, yeah, it's not persistent in the same level, but if you will, if it's education-based, then I believe it has some level of persistence. If it's guilt-based, I don't believe the persistence will be very high.
Yeah, but you'd certainly expect some persistence in thermostat schedule changes.
Well, yes. I think once people change a lifestyle and a behavior, especially when it's automated, they're very likely to keep it. That's correct.
All right. We got a question here. Do present-age DRMS systems, that's demand response management systems, provide such analytics, or is third-party application integration required? I think the movement is towards a lot of these analytics being baked into DRMS systems. You want some automated control of the thermostat to realize these efficiency savings. In our case, we are integrating with Apogee to bring some of their analytics to the table, but from the perspective of the utility using our DRMS, that will appear to be one integrated system. It won't require any customized integration. We've got some questions here around communication protocols with thermostats. So questions like, do these Wi-Fi thermostats come offline? And if they do, how do you get them back online? Also, is Wi-Fi the only option, or do you have things in the cellular, Zigbee, kind of RF mesh spheres as well? We've found that we have the most success with using Wi-Fi connected thermostats. Customers, of course, like the ability to engage instantly with their thermostat and have quick communication from their phone to the thermostat when they want to adjust their settings or what have you. There are some solutions out there in thermostats that do use some of these other communication protocols like RF mesh, but we have not seen a lot of adoption of those, but are happy to discuss those different kind of communication protocols that might fit certain situations better than others. Wi-Fi thermostats do go offline from time to time, although for the most part we've found that customers value the Wi-Fi functionality of their thermostat inherently, their ability to stay connected to it and adjust their comfort and turn down their temperature as they're coming home unexpectedly. So we find that customers are motivated to keep it connected. And in cases where it falls offline and the customer doesn't reconnect it themselves, we have outreach mechanisms we can use, whether it be outbound calling from our call center or what have you, to ensure that those devices stay online. Joel, a couple of questions here about the questionnaire you mentioned. Questions about how many questions there are, how long it takes to fill out, whether you have issues with customer attention span when you're trying to collect information from them.
Right. Those are great questions. So the challenge here is we talk about customers as if they were one group. The average American has no patience with more than 6 or 8 questions. So we typically let them answer the big 6 or 8, which are the size of the house, the thermostat settings, and the basic systems that are in there. What we find, though, is once they've engaged at that level and they get some level of information, they do want to drill down and to add detail. You generally don't want to force it all at the same time. One of the things that we're going to experiment with Converge is a progressive set of questions as the tips come in, where they can engage deeper if they want to refine, if you will, the kind of messaging that Converge is offering. This is, it's really fascinating to me. It's a great question because I received the, what's called the feedback from Apogee's toolkit. Some of you may have heard me talk about this, but it's very humorous. To date, we've had 3.5 million feedbacks in the system in the last 5 years. And most of those come across my desk. And so I have a full life, as I describe it. And the only question I get in that feedback that is relevant here is customers wanting more opportunities to define what's in their house. What's fascinating today is they now want the electric vehicle to be in there. Many of them have solar panels. Some of them are interested in medical equipment, and of course many of them are working from the home, and so therefore it's really an office and not just a house. So there is no way to generalize, but I would say the average consumer wants fewer questions until there's a relevance of importance to answering more. And once the relevance is high, they'll answer any question you ask.
Yeah, and that's really where also having a technician in the house can make a huge difference, right, in terms of reducing question fatigue.
Right. I mean, with all due respect, many of these thermostats can be put in by a certain group of customers, but that 5th wire on some of these thermostats freaks out many of those customers. The technician is, of course, fully capable of knowing what's there and what to do. In many cases, that 5th wire has actually been tucked into the wall, and the customer can't see it. And so, look, there's an advantage to a professional install. We all get that. There are hobbyists who shouldn't be touching this and will attempt to. And the nice thing about the thermostat business is many of these thermostat companies have really stepped up to the bar with their videos and their online toolkits to help the average consumer put it in. But with all due respect, I'm prone to want a professional to touch it.
We got a question in, are privacy concerns with thermostat Wi-Fi usage a barrier here, and how are those successfully addressed? We have not found any privacy concerns around Wi-Fi thermostats. You know, these Wi-Fi connected thermostats are becoming almost a standard product on the market now, and customers are used to things becoming connected in their homes. And so today we've seen the question reference, this is kind of analogous to when AMI was being rolled out, and there were a lot of privacy concerns. So we haven't seen anything like that around concern there. Good question here about whether we focused on residential customers in this webinar, but does it apply to small business programs as well? And answering from Converge's side, yes, it absolutely does. We're majorly expanding, one of our growth strategies is around increasing more small business engagement through this protocol. And I know Joel's got some experience working.
Well, right, and in terms of customer groups that are, the technical term is underserved, meaning the utilities haven't had a strong level of influence in them, these things that look like houses that are used for business really are a very large part of the commercial market. So there's no reason not to consider small commercial almost in your residential thought process, because they're houses used as business, and so why not? And it turns out, in terms of impact, you probably can get a deeper impact in some of these because of the size of the air conditioning loads in those small commercial facilities.
Yeah, and we're rolling out a large program in the Carolinas right now to address these small businesses, which are typically an underserved market. So more results on that soon. Let's see, scanning the question list here.
While you're doing that, this privacy question that you answered, I think my wife speaks on this all the time. It's the question of icky versus helpful. We get things from Kroger in the mail that are coupons to help us shop more at Kroger, and they are the things that we're buying there at Kroger's normally. And so because Kroger actually gives you coupons to shop there for things you're normally buying, it's considered helpful. It is a little icky that Kroger's watching everything we buy, but because they're using the information to actually help us buy it cheaper, we don't consider it icky. But there is a point here where some customers can get sensitive to it, but as long as the tone in it is to help them in a proactive and personal way, what we find is that the privacy issues seem to go away, just as you said. We've actually, in the 3.5 million emails, never had one even remotely indicate a privacy concern.
Yeah, so we do have a question here about if the system encourages more setback to save energy, will that increase peak load when the temperatures go back down when everyone's returning home at the same time? And I think the answer to that's going to be very system specific. If you do see, that's almost a question around, do you want to pre-cool in a sense before a demand response event around 6 p.m. And I know the peak keeps getting pushed later and later in California as more solar comes on the system, and so that could be a problem. I think that's the advantage of having a, in some sense, centralized control over this issue from the utility. So, if end users are incentivized with like a flat kilowatt hour rate and they're going out and buying their own thermostats, sure, then their only goal is going to be to reduce their overall energy consumption, and they're not going to care if it causes a spike in demand when they get home or shortly before they get home.
Plus, you can message those thermostats to soften a snapback effect.
Yeah, so contrast that to a program that has utility control and insight, and you can actually adjust the schedule.
You can, I call it feather it. You don't have to just snap those air conditioners back. You can actually feather them back in.
Yeah. So with that, I think we're going to wrap up a little bit early here, give you guys a few minutes of your day back. There were a few specific questions that rolled in that we'll be happy to reach out to you individually and follow up on. But overall, thank you very much for joining us today. We hope this was a productive and useful conversation, and I'll pass it back to PJ to close out with some logistics.
Thanks, Evan. Great job, Joel and Evan. Really appreciate your presentation. For our audience, we hope you've enjoyed today's discussion. As you log off, please take a minute to complete our survey and let us know how we did. We want to continue to bring you quality webinars just as we have today. Thank you for attending, and this does conclude today's presentation.